Okay, so you can see on the learning guide for the next 2 days, we're going to spend time on what's called significance tests. Last chapter, we found confidence intervals. We were looking at sample data and trying to predict what interval the parameter would fall in. It might have been a proportion, it might have been a mean. Those were the two we focused on. This chapter, we're going to talk about testing against a claim. And so it's called a significance test. And we're going to actually have many different types of significance tests throughout the next few chapters. This chapter specifically just focuses on significance tests about a population proportion and about a population mean. So we're talking about one single sample that we take, and we're trying to see how does that match with a specific claim that has been made. And then in later chapters, we'll talk about, well, what about if I have 2 samples and I want to find the difference in those 2 samples, like men versus women on some kind of a topic or something like that. And that'd be 2 different groups, 2 different samples that we're looking at, and those are all coming up in later chapters. So for this chapter, we're talking about one specific sample, and for the most part, either a proportion or a mean that we're trying to find some kind of information out about. So there's an activity paper that's in front of you, but I want you to jump to the paper that says Significance Tests, the Basics. So first of all, some things to fill in on your notes. A significance test is a formal procedure for comparing your observed data with some kind of a claim. And we want to assess the truth of that claim. So I make a claim. We're going to investigate this one today. Mrs. Robert is an 80% free throw shooter. That is my claim. We're going to investigate that claim by doing what? Probably having me shoot some free throws. And those free throws that I shoot are going to represent our observed data or our sample. And then what we're going to do is conduct a test regarding what did I do with that sample compared to the claim. Okay? So filling in the rest of this, a claim is a statement about a parameter. Remember, a parameter is a number that comes from the population. So a population proportion, a population mean. It could also be a population standard deviation, or anything like that. Yes, I did start recording. Thank you for asking.
You actually get to go.
Yeah, we're going to go shoot free throws in a minute. Well, I'm going to shoot free throws. We express the results, and this is key right here. The results that we're going to get are in terms of a probability that measures how well the data and the claim agree. So let's just talk about this and get it off the table right now. After we do a whole significance test, in the end result, we get what's called a p-value, the probability that something occurs. And what we're getting, if that's a small probability, it means that we don't match up with the claim. If we get a large probability, then we are matching up with the claim. Okay? But the key is when we write our hypothesis, you're going to see it later on this, after we go do this activity with free throws, is we have what's called our null hypothesis and an alternative hypothesis. And what we're trying to do is gather evidence against the null hypothesis. So right now, I'm going to make a claim that I'm an 80% free throw shooter. I'm going to go shoot some free throws, and we're trying to see, does what you get kind of match up with that claim? Or am I far enough off with my free throw shooting that you have evidence against my claim? And that would be, if you think about me shooting free throws, and you get a certain value, how does that match up with what you would expect to have happen? If 80% was really my true value for shooting free throws, does it mean I have to get 80% when we go downstairs? No, but I should get within a certain range that seems still likely or probable. And if I get outside that range, it's evidence against my claim. Okay? Yes, sir? That's a good question. So when we start to create significance tests, the question was, how much evidence against the claim do we need? We usually start off with something called an alpha level. It's our significance level of 5%. And so that's sort of our cutoff. If we get a probability of something happening that's less than 5%, that's good evidence against our claim. And if it's above 5%, we just say we don't have evidence against the claim. We don't say the claim is true. We just don't have enough evidence against it. Does that make sense? So that's like the big logic behind this, what we're going to be doing. So take out the activity, I'm a great free throw shooter, and we'll talk through what you're going to do when we're downstairs. So First of all, fill this in. I did used to actually, I think, be an 80% free throw shooter. But anyways, we're claiming that I still am an 80% free throw shooter.
That's pretty good.
Okay? And I haven't shot free throws in a very long time. So our expectation is I'm probably less than an 80% free throw shooter, right? But my claim is 80%. What I want to do on here is have you draw a line that represents our null hypothesis. So we're going to make these tick marks represent like 10%, so 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and so on. 0.9 and 1. And draw a line at the 80% mark. Now, we're not going to do anything with this graph right away. What we're going to do when I get downstairs is I'm going to shoot 5 free throws. And I want you to record the outcomes over here. So for number 1, I don't think I told you how you have to do it, but let's say number 1, I make it. Maybe you put like a check mark or an M or something like that. You guys can decide. And here what we're going to do is keep track of the cumulative proportion of made shots. So don't write this down, but let's just say I got a make, and then miss, miss, miss. Here, right away, the make, I get 100% because it's 1 out of 1. And then I still have 100%, 2 out of 2. But then I would have only 2 out of 3, so 0.67, right? And so on. So that's what's going to go in this column. I would say just let's worry about filling out the outcomes. And then if you can do some of this along the way, do it. Otherwise, we'll just come back to the classroom and calculate those with using our calculators if we need to. Does it make sense? All right. So you can have one person keep track, and then we'll all actually, no, bring your papers and some clipboards. At least 2 people keeping track, because I don't want anyone, like if you mess up, I don't know. So we have something to compare with. And then I can, so. Okay, so this is what happened with my shooting. We've got the dark circles are made, the open circles were misses. The cumulative proportions were amazing at first. I'm such a good free throw shooter, and then something happened. Oh, started talking and moving around a lot, and it was distracting me apparently. But we're not talking about that. So what we want to do just kind of see what's happening is at 1 I had 100% made, 2, 3, 4, 5, all the way up actually through 7. I made 7 in a row. And then my 8th one I missed, and it dropped me down to 0.88 for my cumulative percent. You guys see what's going on there? And then I hover at around the 0.9s. I'm going to just jot down, like at the 15, what happened was at 0.93. And then at the 20, I was at 0.95. And at 25, I was at 0.92. So up until that point, the entire time I was hovering above my null hypothesis. But then I did start to drop below. At 30 shots, I was at 0.87. I guess I'm still above there, but 0.87. And then at 36 shots, I was at 0.8 or 0.78. And then 42 shots, 0.76. And at 50 shots, 0.74. So what you can see in the long run, I actually start to sort of hover around my hypothesis line. So what's probably going to happen when we run this test is we're not going to have strong evidence against the claim, most likely, okay? But we'll see what happens. But that's what happens in the long run. I just wanted to show this is like, if you don't see a leveling out happening and you're conducting a study, if you do want to go into this intensive detail, then you would want to keep going until you see some kind of leveling out, meaning that there's actually some number that we would be approaching probabilistically, if that makes sense. So, okay, what we want to do from here is answer some questions. It says, do you have enough data to decide whether my claim was valid after only 5 free throws? I asked you that question and you said no. The number of successes was equal to 5. And so if we had thought about like doing n times p hat, trying to make it bigger than 10, we wouldn't have met that criteria. Okay, so everything we did with confidence intervals you're going to see is going to come back. If we want to talk about probabilities, because that's what we're going to do with this test, is find the probability that something could possibly happen, we have to base it on those conditions of random, normal, and independent again. Okay. But that comes up later, so don't worry about it a ton right now. If I did shoot up to 50 shots, it says how large of a sample would you want, though, to make my condition or to make a decision? And you guys were saying probably around 30, just because that seems to be the number. But remember, with proportions, 30 is not the magic number. It's n times p has to be bigger than 10, and n times 1 minus p has to be bigger than 10. So if you were thinking about my claim of 80%, you would want to make sure just that if you had like 13 shots, 13 times 0.8 gives you about 10.4. So even if we only did sample 13 of my shots, it would probably be okay. Does that make sense? Okay. All right. On the back side of the activity, it says, let's say Mrs. Robert made a claim. So first of all, did we answer a question? We didn't yet. Let's say that Mrs. Robert made the claim that I could make 80% of the free throws. Oh, that was our first claim. Let me do a different one. 60%. So looking at this data, with the 80%, we said, well, we don't really know. Am I an 80% free throw shooter? I probably could be. I shot 74%. It's a little low, but I also had way above that for a period of time, right? But what if I had told you I'm a 60% free throw shooter? Would it be easier or harder to reject my claim? Easier. Yeah, it would be easier to reject my claim. You would probably say, no, you shot like way better than that. You're probably better than a 60% free throw shooter. So we're going to reject the 60% and think you probably have a different free throw percentage. It might not be 80, it might be 70, but it's probably different than the 60. Does that make sense? What if another player claims that their proportion of made free throws is 0.8, like I did, but the player only makes 10 out of 24, or 10 out of 25, so 40%. What would you think about that person's claim? Yeah, they're probably, the claim is false. What if that same player, though, made 19 out of 25? It's probably within, we haven't done any calculations because we don't want to say it's within 5%. We would want to say if we did the sampling distribution, these are the numbers we should see. Does that make sense? But so I wouldn't say that. I would just say this is closer to the claim, 0.8 claim. So I'd say it'd be harder to reject it. That makes sense? Even though it is still less than the claim, so maybe they are worse than an 80% free throw shooter, it's not far enough away to make any kind of assumption about that yet. Increasing the sample size helps us be more certain that the difference between the observed proportion and the hypothesized proportion is not due to sampling variability. When I first started off and I made 5 in a row, you were like, whoa, maybe she's not an 80% free throw shooter, maybe she's way better. Right? But as I continue to go on, I mean, that 5 was maybe a lucky streak, right? And so as we get more numbers in our sample, it's easier to kind of see, was it just because of chance variation that we had those 5 in a row, or maybe 5 misses in a row, or was it because of how good this person really is? And so increasing the sample size helps us be more certain that the difference between observed and hypothesized, or you could say the claim, is not due to chance. Actually, I'll say to sampling variability. It's kind of chance, but. And then it's easier to reject the hypothesized proportion when the value that comes out from our sample is way different than it. So like we were talking about this 60% versus what I had 74%. It's going to be easier if your So it's easier to reject the hypothesized proportion when the sample proportion and hypothesized are very different. Or there's a large difference between them.